Hello. Today we're going to take a look at how to graph sinusoidal equations, otherwise known as sine and cosine graphs, and especially as we start messing around with changing their amplitude, their period, and their horizontal and vertical displacement. Okay, let's take a look at an easy way to keep track of all that stuff. Okay, today's mission is to find an easy way to graph the equation y equals cosine of 2 times parentheses theta minus 15 degrees and parentheses plus 3. So to do that, we want to go back to the parent equation and remember some things about it. So if we start just by remembering what are the important points in our y equals cosine theta graph, we remember that the period is 2 pi or 360 degrees. Our problem mentioned 15 degrees, so I'm going to do this one in degrees. And so we remember that halfway through our period is 180 degrees, and halfway through each of those is 90 degrees on either side. And now we have the 5 points along our x-axis. And then we're going to remember that our amplitude is up 1, down 1. The highest we're going to go on this cosine parent graph is up 1, and the lowest we're going to go is -1. And then we're going to ask ourselves, okay, does cosine theta, does that begin at 0 or does that begin at 1? That's right, cosine begins at 1, and now I can dot my points and go ahead and draw my curve through them. And that will repeat every 360 degrees, going this way and that way. So I'm going to load those points into my table over here. And if you are unfamiliar with this, this is something that is worth memorizing. It's good to have this up your sleeve. Okay, so now I'm going to go ahead and take a look at the equation we're meant to graph. To go ahead and transform from this parent graph to this graph, which has no change in amplitude, right? My amplitude is the coefficient of my whole sine or cosine. So there's nothing there. That's an implied 1. To take a look at a period shift, that's this right here, the coefficient of the theta. And then to take a look at a horizontal shift, that is the added or subtracted within the parentheses, and then a vertical shift, and that is the added or subtracted outside of the parentheses. So what I'm going to do now is I'm going to make a table with 4 things, and I'm going to adjust stuff based on my parent graph. The first thing I'm going to do is in these middle 2 columns, instead of having theta and cosine theta, my new theta is comprised of these actions, 2 times theta minus 15. So that's my new theta. And in there, I'm going to put all my salient points. Similarly, my new output is cosine of those points. And so I'm going to put all of my salient answers there. Now, that is not the actual theta I'll be putting in, nor is it the actual output I'll be getting, because in terms of output, I need to take all of these points and add 3 to them. So I would take everything that's in my output column and I would add 3. Similarly, to figure out my input, I need to know what theta I would put into this to make a 0. So I just do some math, right? I set this equal to what I need it to equal. Well, I divide by 2. 0 divided by 2 remains 0. Then I would add 15 degrees to both sides and find that my first theta is 15. If I plug 15 in, I create a 0. And now I do it again to find out what my 90 degrees would be. So I divide by 2, get 45, add 15 to both sides, and find that if I input 60 as theta, I wind up with a 90, and so on and so forth. And I would find, and that creates 0 through 360 degrees as my inputs. When I take the cosine of those inputs, I get these standard outputs, but then finally I add 3 to them all. So that's my theta column. That's my cosine of 2 times theta minus 15 degrees, all plus 3 column, and that's what I'll be graphing. So as I go ahead and label my axis, right? My first point is 15 degrees, then all the way through to 195, and again 1 through 4. And so I'll go ahead and plot. And this is the graph of this. Okay, play around with that. Leave any questions you have in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.